Okay, continuing with finding zeros. This time we're going to talk about multiplicity and what that means. If I take this first example and I factor it like normal, this is a difference of squares, and it's going to factor into 7 minus x, 7 plus x, which means when I set these equal to 0, I get x equals, that one's going to be positive 7 and the other one negative 7. So this means that my polynomial is going to cross at positive 7, negative 7. It is a negative leading coefficient. You look at which one has the highest degree. It's an even, so they're both going to be pointed down. So here's what my graph will look like. Your constant in a polynomial is always your y-intercept. So this graph is actually crossing the y-axis at 49. Now let's look at this next one. Factoring, I've got a 2 in common. X squared minus 7x plus 12. And factor that once more. X and x multiplies to 12, adds to negative 7, negative 3, negative 4. Set them equal to 0. So x equals 3 and 4. I'm going to have a y-intercept of 24. So I know I'm crossing on the positive side. I've got x-intercepts here and here. This is an or a positive leading coefficient with an even degree, which means they're both going to be pointing up. So it must look something like that. When a question asks you to analyze a polynomial function, typically you're wanting to find the zeros, you're wanting to find your x-intercepts, your y-intercept, and your maxes and mins. So we're going to do that all on the calculator. You also want to look at your end behavior. Okay. We have found all this in the calculator before, so I'm going to trust that you can put it in the calculator, you know how to find it, and we're going to go over what the answers would be to describe a polynomial function. Okay, finding the zeros in the calculator, I find that there is a 0 at x equals negative 1.82, which is my x-intercepts. My y-intercept, my graph is going to cross the y-axis always at my constant, so negative 3. Maxes and mins. This graph has a minimum at negative 1, negative 5. A maximum at 0.11 and negative 2.9. End behavior, it is rising on the left side, falling on the right side. And with this information, I would be able to give an accurate sketch of this polynomial. I know that it's going to cross the x-axis at almost negative 2, the y-axis at negative 3. It has a minimum at negative 1, negative 5, so it actually goes lower right there. A maximum at almost 0 and little above negative 3. And I know that it's got to rise on the left, rise on the left, fall on the right. So the whole point of analyzing is to be able to give enough information that someone could sketch this polynomial. When you are given the zeros of a polynomial, you are going backwards. So if x equals negative 2, I'm going to get that equal to 0 and make that x plus 2 equals 0. And that's one of my factors. So x equals 0 will just be x. It's already equal to 0. And x equals 5 will be x minus 5 equals 0. So that's a factor. I'm going to take all these factors, x, x plus 2, x minus 5, and multiply them together. I'm going to start by multiplying these two together. X squared minus 5x plus 2x will give me minus 3x minus 10. Still multiply by x will give me x cubed minus 3x squared minus 10x. Now we learned with the bounce or the pass-through bounce and wiggle activity, if a 0 has a multiplicity of 2, it is bouncing off at negative 2. If it has a multiplicity of 1, it is going through pass-through. Okay, so if I have a multiplicity of 2, that means I have x equals 3 and x equals 3. And I also have an x equals 2. So here I'm going to have x minus 3 times x minus 3 times x minus 2. Oh, that was a 0 of negative 2, so that's a plus 2. These two together first will give me x squared minus 6x plus 9. When I'm multiplying polynomials that are bigger than 2 terms, I like to put them in a box. You can do it however you want. This keeps my work much neater. X cubed minus 6x squared, 9x. Okay, so I'm multiplying on both sides. And then I get 2x squared minus 12x plus 18. So coming out of this, I have x cubed, combining my like terms, negative 4x squared, like terms again, negative 3x plus 18. Make sure I do have the right degree of 3, we're good to go. Okay, if I want a 4th degree polynomial, so it's got to have x to the 4th, 3 real zeros, so it's crossing the x-axis 3 times, and a positive leading coefficient. Okay, so if I have to touch the x-axis 3 times, that means, since I'm wanting a 4th degree, one of these has to bounce. If I have a positive leading coefficient, they're both in the positive leading coefficient and even degree, my end behaviors are both up. Lots of different options for this. If I want to go up, bounce off that one, up again. I could have maybe put all 3 of them over here, gone up, bounced off of this one, through and through. That would be a 4th degree. Lots of different options.